Hi everyone, welcome to the 25th and final episode of this series. So I'd like to start off just by implementing a little score system. Just create a new C# script, call this something along the lines of scorekeeper. And I'm going to create a new empty in the hierarchy, call this, I guess, just scorekeeper as well. Let me just put that at the top, and I'll add the scorekeeper script to that. Let's open the script up. And we're going to want to be notified in here each time that the player kills an enemy. So currently the only way to do that would be to subscribe to each enemy's on-death event. And it'll be a little bit tedious having to keep track of whenever a new enemy gets spawned into the level. So what we're going to do instead is just head over to the enemy script and go to create a static version of the on-death event so that we only have to subscribe to it once. Let's say public static event system.action, call this on death static. Alright, so if we just head down to this takeIt method here, where we have our death condition, we can say if on death static is not null, then we're going to want to call it just by saying on death static and parentheses. Okay, so now in the scorekeeper, let's make a start method and a void on enemy killed method. And we can simply say enemy dot on death static plus equals on enemy killed. Alright, so let's have a public static int for the actual score variable, and we don't want this. We don't want other classes to be able to set this just to get it. So we'll say get private set, close curly brackets, and in the onEnemyKilled method we can just say something like score plus equals 5. So now we'll get 5 points for every enemy we kill. We could also maybe add some simple sort of streak functionality so we get rewarded for killing enemies faster. So let's keep track of the last time that an enemy was killed. So last enemy killed time, and the sort of current streak count. And then also a float for sort of how long can pass in between kills before the streak is lost. So we can call this maybe the streak expiry time. Set that equal to maybe 1 second. Alright, so in the onEnemyKilled method, we can say if the current time is less than the last enemy kill time plus the streak expiry time, then the player was in time, so we can increase the streak count, just say plus plus. Otherwise, the streak is lost, so we'll say streak count equals 0. Alright, and then we're going to want to set the last enemy kill time. So you can just say that's equal to the current time. Okay, so now instead of simply adding 5, we can maybe do something like add an extra mathf.power of, say, 2 to the streak count. That should be nice. So as you kill more enemies, your score sort of goes up exponentially, as long as you're quick enough. We're going to need to cast this mathf.power to an integer, since the method returns a float. Also, one thing we need to be very careful of when we're using static events is that we actually unsubscribe from them, because if the player were to play through the game once and die, and then sort of say play again, this static event will have been now subscribed to twice. So each time you kill an enemy, you'll actually get double the score. So we don't want that exploit available. So we're going to have to detect when the player dies. So let's have a little void on player death. And we can just say find object of type player dot on death and add this on player death method to that. And then here we can simply say, let's actually just copy this line, enemy.onDeathStatic minus equals on enemy death, and we've successfully unsubscribed. Okay, so back in Unity, we're going to want a little score UI. So let's open up the canvas and I'm going to create a new UI text. Call this the score UI. And I'm just going to drag this out horizontally and just align it in the center. Maybe change these to overflow so I don't have to worry about it clipping, and change the font. Let's ramp up the font size a little bit. Can maybe make the score just always be a 6-digit number. So something like that looks quite nice. Maybe make the color white, and let's give it a little UI effect, maybe a outline. Can change that to can make that 2 by 2. Yeah, that looks decent. So let's just open up the game UI and go to get a reference to this score UI. And then let's just make an update method. So each frame we can set the score UI's text equal to, and we'll just grab the score from the scorekeeper. So scorekeeper.score. I'm going to want to always maintain these 6 digits. So if you've got a score of 5, it should be 0000005. So the way we can do that very easily is just by saying scorekeeper.score, and we'll cast that to a string. And you can see that we can actually give this a string format. And there's a nice way of writing this. We just say D, and we want 6 digits, so we say D6. Okay, so let's save and try this out quickly. And just remember to apply the score UI to that field there. Let's press play, and let's go kill some enemies quickly. And as you can see, that works. Alright, let's not get too caught up in the game yet. The next thing I'd like to do is just have a little health UI across the bottom of the screen. So we can maybe make a little empty child to store that under. Call this the health bar. Okay, just move this down, drag it out across the width of the screen. Okay, so next we're going to want to add in a UI image. Just parent that to the health bar. You can call this the bar. And I'll also stretch this one out to fill the width of the screen. Make it nice and thin, something like that. And give it a reddish, healthy color. Alright, probably look better with a sort of slight outline around it, so I'll just duplicate that. Can call this the backing or outline. We'll make that a sort of dark grey, and just increase the height so that it sort of juts out behind the actual bar. I'm going to go onto the bar object and just grab this little blue circle, which is the rect transform pivot, and just put that on the leftmost edge of the screen. And all that means is that when we scale the object, it will scale from right to left, such that 0.5 is sort of the dead center of the screen, 0.25 is a quarter, and 0 is no health remaining. Okay, so let's open up the game UI script again and go to get a reference to that rect transform of the health bar. Okay, so we're going to need a way to access the player's health. So that's actually stored in the living entity class. So at the moment you can see it's protected. We want to make it public, but we want to make sure that other scripts can't modify the value. So once again, we'll just do this get, and then we'll say protected set, so that the derived class, the player, will still be able to set it. So it's not private, it's protected. Okay, save, and let's get back to our game UI. So we're going to want to actually keep a reference to the player. So we can say player, player, and we'll just set them over here. Player equals, find object of type player, and just separate this. All right. Then in the update method, let's say float health %. So we want this to be a value from 0 to 1. So this is equal to the player's current health, so player.health divided by however much health the player started with. Okay, so we can then say health bar.local scale is equal to a new vector 3 with an x of health %, and a y and z value of 1. All right, let's save that. And of course, at any moment the player could be killed and the object destroyed, so I just want to be safe and say if the player is not equal to null. Okay, that way no errors will creep in. So save that. And let's just remember to actually apply the bar over here. Let's test this out quickly. So I'll just let these enemies knock me around a bit. Okay, so the player is actually being destroyed before the UI can update the health bar. Okay, so if we go into monodevelop, what we can do is outside of the null check, we can say float health % is equal by default to 0. Then only if the player is not null will we set the health % to its real value. And then we can just move this outside of the null check so that it always gets set regardless of whether the player is alive or not. Okay, so let's just confirm that that's working. Okay, so the health bar is going all the way down. This game over screen, however, is supremely ugly. So I think what I'd like to do is, first of all, just make it not fade out completely so we can sort of still see the level slightly behind it. And then the score UI needs to sort of be moved down below the game over. And we must also remember to unhide the cursor so we can actually easily click on the play again button. It's almost impossible to find at the moment. So let's create a separate score UI object. And we can call this the game over score UI. And we can just put that in the game over UI object. So let's just see what sort of level of fade we want. Perhaps something like that. I want it to fade over all of these other elements, so I'll just move the fade and the game over UI to the bottom of the canvas so that they sort of render on top of everything else. Alright, so this game over score UI can be moved sort of over here. Can call this the game over text and just drag that up here, make it a bit bigger. Maybe the score can sort of be more grey. I don't know, it's still reasonably ugly, but it's perhaps an improvement. Move this play again button down a little bit lower. We maybe also want a return to menu button, so I'll call this play again, and then create another one. Return to menu. I'm just going to make these capital. Alright, just something like that. Oh, I forgot to set the fonts on these. Let me do that quickly. Okay, that's already a big improvement. Okay, so obviously when the game ends, we're going to want to hide all of these other elements because they look a bit ugly in the background there. So let's get going on this. I'm going to create a new public text. Call this the Game Over Score UI. Also, we're going to want a method for returning to the main menu, so public void return to main menu. As you can see, we're still using the old application.loadLevel here. Let's just get with the times and say using Unity Engine.scene management. Let's update that to scene manager dot load scene game, and we can copy that for the return to menu and just type menu. Okay, so when our game over method is called, first of all, we don't want the fade out to be completely black, so let's just define a custom color. So new color, so 111 to get the color to be black, and then we'll change the alpha to say 0.9 perhaps. So now we want to hide the sort of in-game UI elements. So let's say score UI.GameObject.setActive false. We also want to hide the health bar as well as its backing object. So let's say .transform.parent.GameObject.setActive false. We're going to want to transfer the score UI text over to the game over score UI text. So let's say game over score UI.text is equal to score UI.text. And finally, we want to show the cursor. So let's say cursor.visible equals true. Okay. Let's go into the canvas and just drag in the game over score UI. Let's also go into the return to menu button and just make sure that this is set to return to menu. And now we can hide this, and let's just reset our fade so that it's fully transparent, and let's give it a go. So I'm going to go into the next level and just let these guys kill me again. I am an idiot. Black is not 111, but 000. Yes. Okay. Let's try that again. Okay, I want to change the highlight color of these buttons to match the menu, but yeah, so these are nice blue, but yeah, that seems to be working very well. So let's quickly grab these two buttons. I'm not going to worry about getting the exact same color, just something bluish is fine. All right. Okay, so there are just a few loose ends left to tie up. One of which is that little bug that I introduced a few episodes back where all of the enemies turn red when one of them attacks the player. That was because I wanted to set the color of the enemy death particle effect, so I used shared material, which is shared, so yeah, that's why they all turn red. So let's find an alternate way to set the color of the enemy death effect. So I'm going to make a new material, call this something to the effect of enemy death particle. Alright, so I'm going to set its shader to a default sprite shader, and let's apply that to the enemy death effect. So under the renderer tab, we can just set the material equal to enemy death particle. So all that this means is that we can now set the color of the effect simply by playing with this start color field. So if we make that red, it's red, and if we make it some other color, it will be that other color. Yay. So let's go into the enemy script. So here in the set characteristics is where I made this shared material blunder. So let's change that back to regular material, and we'll want to set our death effects start color equal to a new color. And I'm going to say skin color.r, skin color.g, skin color.b, and then I'm going to set the alpha to 1. And the reason I'm doing it this way is that in the spawner, all of my colors have got no alpha, and that just means that the effect would be completely transparent if we didn't do something about that. Alright, so let's just confirm that these are working. Just want to bring some enemies back to the first round. So let's set that equal to 40. Give it a go. Cool, so it is working as intended, and only one flash is red. Fantastic. So the next thing I'd like to do is make the player die if the player falls sort of off the map. So let's go into the player script. Where's that? Over here. So in the update method, we can just do something simple like if transform.position.y is less than some threshold value, let's say -10, then we can just call take damage with however much health we have, so that will kill us. Okay, let's test that out quickly. Just run off the edge of the map here. And I die. Great. Alright, so the next thing I'd like to do is to go into the music manager and just work on this script a bit. So I'll delete the update method since that was just for testing earlier on. Let's make a void onLevelWasLoaded, which is one of the methods that Unity calls automatically. It takes in an integer for the scene index. Let's also make a void playMusic and a string variable for the scene name, the sort of currently active scene name. So in playMusic, we will have an audio clip called clip2play, and set equal to null by default. And then we're just going to set that depending on which scene we're in. So if scene name is equal to, say, menu, then clip2play will be equal to our menu theme. Otherwise, if scene name is equal to game, then the clip2play is equal to the main theme. Obviously, if you've got more scenes, then you can just add them in. So now we'll say if the clip2play is not for some reason null, then we're going to say audio manager instance playMusic clip2play, and we're going to want to play it again once it has finished playing. So we're going to invoke this playMusic method. So we'll say invoke playMusic, and we'll invoke it in however many seconds the track takes to complete. So in clip2play dot, not duration, what's it called, dot length, all right? So in onLevelWasLoaded, let's actually just quickly import scene management here. So using Unity engine.scene management, we can say string new scene name is equal to the scene manager dot get active scene dot name. Then we can say if the new scene name is not equal to the current scene name, in other words, we've actually switched to a new scene, then we will want to invoke play music in just say 0.2 seconds. And I'll explain in a moment why we invoke instead of calling it directly. But first, of course, we want to actually set the current scene name equal to the new scene name. Alright, so the reason for this invoke instead of calling the method directly is, remember how we have an audio manager in each scene, and the one gets carried over and then the duplicate gets destroyed. The problem is that this onLevel was loaded will be called before the object is destroyed, meaning that play music will be called twice, which will screw up any sort of fading that we're trying to implement for the music. So instead we just invoke it with a small delay so that the one that's destroyed never gets called. Now, as of Unity 5.3, it seems that this onLevel was loaded method doesn't get called for the very first scene, only for the scenes after that. So if that's the case in whatever version of Unity you're using, then I'm just going to call onLevel was loaded manually from the start method. Just give that an index of 0. Okay, let's quickly test that out. So I'm going to hop over to the menu scene and press play. Okay, so we get our menu theme playing. Let's press play here. And we do get a nice little crossfade into the next track. So that's all good. Okay, so just as a sort of finishing touch, let's import the effects standard assets package. Just import all of those. And we can load up the game scene. I'm just going to enlarge the game window, and I'd like to preview the effects with the largest map, so the 4th map. Let's go into the main camera and add in a new image effect. Let's choose perhaps a vignette and chromatic aberration. Okay, so I've currently got this strange bug in Unity 5.3 where adding image effects completely distorts the level. I'm just going to save and reload Unity real quick. That seems to mostly fix it, although you can still see it's doing weird things on this right-hand side here. If I resize the game window, though, it appears that those go away. Hopefully Unity will fix that soon enough. So let's play around with this a bit. Just add in a nice little vignette, some blurred corners. We can also maybe add in some screen space ambient occlusion, just to sort of block out some of the light around the obstacles. I'll just play with the settings here a bit. Something like that is maybe nice. Okay, and I'd also just like to add in a color adjustment curve. And we can play around with this a bit. Maybe add in a little bit more red, a little bit more green. Maybe something like that looks quite nice. So let's try that out. I'll just go back to the first map here. Okay, let's try that. Alright, so I'm pretty happy with that. I think it looks very nice. All that remains to be done really is to go into the spawner and disable development mode, and we can save, and at least as far as I'll be taking it, this game is complete. So I hope you've all enjoyed this Create a Game series and that you've learned some interesting things from it. I'd just like to thank everyone who has pledged to my Patreon so far for their very kind support, and I hope to be back soon with a new game development tutorial series. Until then, cheers.